Bueno, buenas tardes para todos. Gracias por acompañarnos hoy en otra nueva reunión del Jueves del Agua. Hoy tenemos un invitado muy especial, Gergely Török, de Hungría. Él actualmente está en Budapest, en Hungría. Y pues ha hecho un esfuerzo grande para acompañarnos hoy y mostrarnos toda la investigación en el manejo de sedimentos sobre el río Danubio. Allá él está en Hungría y son ahorita las 11 de la noche, así que pues le agradecemos nos haya aceptado la invitación. Y bueno, la idea es que tratemos la reunión de hoy mayormente en inglés, para que él también se sienta acogido por nosotros, porque bueno, él no sabe el español, entonces tratemos de, él va a hacer la presentación en inglés, pongamos atención y al final si alguien tiene una pregunta y la quiere hacer en inglés está bien, si no la puede hacer en el chat y yo la puedo traducir para que él pueda responder. So Gergely, so I was introduce you a little bit. We really want to thank you because you are making this effort. I know it's 11 p.m. in Hungary. So yeah, thanks again. So you can get started. We want to see how you are working the Danube River and learn something about your research. Thank you.
Thank you very much. First of all, thank you for the invitation. It's a pleasure. And yeah, I have never been to Colombia yet, South America, but at least partly I am there now with you. So thank you, Andres. Thank you for the invitation. I thought that I'm going to talk about mainly the main part of my presentation will be about my PhD, the results of my PhD. I had my defense 2 years ago, and the rest part of my presentation will be something about ongoing research projects in Hungary involving our research group. So as an introduction or a few words about the research lab, this is a very small one. The head of the research lab is called Sándor Baranya. I am the only one postdoc, and there are 5 other PhD students. And this small and quite young research lab consists of people from partly from Budapest University of Technology and Economics, and the rest, like for example me, we are a researcher from Water Management Research Group, which is included in the Hungarian Academy of Science. Here in this map you can see River Danube. This small blue line represents the river. Just for helping you, this is Italy, and this other bigger country is Germany. I guess you know these countries better than, for example, the smaller one is Austria, and next to it there is this smaller country. This is Hungary, and the capital Budapest. That is the most known, best known place from Hungary. As to the measure of my country, it's more or less the same as a smaller state in the United States. So River Danube flows through 10 countries within Europe. It is around 3,000 kilometers long, and the mean discharge at the delta is around 7,000 cubic meters per second. So again, this is Hungary, and mainly we focus on this section of the river, which can be seen here on this satellite map, because the ongoing morphodynamic processes are quite complex here, and that's why it gives us many research topics. I will talk about more detail later on, but here, as you can see, a hydropower plant, a water dam was built 30 years ago or something, and it has had and still has important effect on the downstream of the river. Originally the Danube has middle course meandering pattern here, and also, yeah, again I will talk about it later. But here there is a confluence zone because there is a smaller tributary here. As to the bed material, bed material is quite varied both in time and space. As you can see, for example, on this photo, the bed material is very coarse in the mainstream, and it can be easily armored. Meanwhile, the smaller and finer sediments can settle easily in the near bank regions, as for example in growing fields. So here these white sticks are wing dams or groins, and typically this part of the rivers, the growing fields are very, very fine. So as I mentioned,
perdón, Jerek, Lipe, Andrés, ¿puede apoyarnos ahí un poco en la traducción, unas pausas? Gracias.
So they are saying that they want to like translate a little bit
okay.
what you have said so far. So if you can go back like one slide.
Or I can give you the remote control.
Okay. Let's see. Okay. Bueno, él empezó aquí mostrando la ubicación de Hungría, teniendo como referencia a Italia, Alemania. Entonces ahí al lado de Austria está Hungría y Gergely está ahorita en Budapest. Entonces acá nos está mostrando su sitio de estudio. Y está diciendo acá que en esta zona la granulometría del río en esta parte pues, tiende a ser el grano de sedimento grande. Bueno, acá mencionaba que hay una represa en este sitio que ha influido en lo que es la tasa de sedimentos que caen sobre la zona de estudio. Yeah, go ahead, Gergely. I think that was a brief summary that helps.
Okay. So in this figure, you can see the hydropower plant, which, as I mentioned, it was installed 30 years ago. And presumably because of this hydropower plant, a huge or important drop in the sediment supply happened during these 30 years, and therefore very, very important bed decision happened. We calculate this bed decreasing around -2 meters. And this bed level change caused many problems, for example, for the navigation or for the agriculture. And what we are most interested in is what can be expected for the future.
Okay, let me rephrase that. Bueno, lo que está diciendo acá es que la presa que construyeron ahí hace 30 años, pues ha influido bastante en lo que es la tasa del transporte de sedimentos. Y ha habido, Gergely, you said like 2 meters, like the scour, like minus 2 meters with respect to the original level.
Yes, yes. Yes.
Entonces la presa ha hecho que se forme como un hueco de 2 metros ahí en esa parte de aguas abajo. Yeah, go ahead.
Okay. And another interesting phenomenon can be seen. So here is the tributary called Mosoni-Danube, and the next slide will show this part of the river here. And as you can see, or this satellite photo shows quite well that these tributary transports much higher concentration of suspended sediment load compared to river Danube. And the mixing zone can be very, I would say, interesting, or interesting at least for us, because the mixing zone, the length of the mixing zone can be more than 20 kilometers long, which we wouldn't expect that long length for that.
Okay, give me 1 second. O sea, hay un tributario que cae sobre el Danubio y tiene una zona o sea, ese tributario trae mayor cantidad de sedimentos que la que maneja el río Danubio, entonces hay una zona de mezcla entre los dos ríos que llega hasta por 20 kilómetros aguas abajo. Keep going.
Okay. So the main goals of our research or interests are mainly to explore the ongoing processes and the prediction. And for that, we do mainly field measurements. Until now, we did only campaigns, but our plan is to establish a sediment transport monitoring station here, and that will be our next step. And the other tool which we use is numerical modeling.
How are you going to measure the sediment in that site?
Here?
Yeah, you said like you're gonna put the monitoring.
Yeah, we will put their devices like, or install their devices like OBS and ABS and horizontal ADCP, but I'm going to talk about this. Do you want to translate it now?
Yeah, sorry, I lost a little bit my connection, but
okay.
So you said that you were going to use ADCP and what?
I'm going to talk about this.
Okay, you are going to explain that later.
Yeah.
Okay. Bueno, Gergely dice que debido a eso, a lo que le aporta el tributario, pues van a poner sitio de monitoreo y crear un modelo numérico para tener contabilidad del transporte de sedimento en ese lugar. Sure, keep going.
Okay. So my part, at least in my PhD, was mainly the modeling, and the first question was, is there any reliable sediment transport model which is capable to deal with the fine and the coarser sediment particles motion at the same time or not? As I've found in the literature, the sediment transport models are validated for sand transport or for coarser gravels, but there is not really one which would be able to deal with very fine particles and also at the same time with very coarse gravels. So the problem was this at the beginning of my PhD, and that was my goal, to establish a new method which is capable to calculate the two kind of sediment transport at the same time.
So considering both like small and coarser particles.
Yes, yes.
So, en la tesis de doctorado de él, entonces, hizo más la parte numérica, de modelación numérica. Entonces, haciendo la revisión de literatura, pues él encontró que los modelos están diseñados más que todo para las arenas, o sea, granos más pequeños, pero en el caso del Danubio y en ese sitio, pues hay una mezcla entre grano grueso y delgado. Así que el reto era como desarrollar un modelo para esa combinación. Yeah, keep going.
So the Fine model is a well-known one, and with many proving examples can be found in the literature, and this was validated for the sand load. And meanwhile, the Wilcock and Crow model is a very quite new one compared to the other one, to the previous, and it was validated and developed for sand gravel mixture, and it is expected to calculate much more reliably the selective erosion and bed armoring processes. So first of all, I tested these two models. For that, I used a 3D flow model called SIM2. This is a Norwegian code. And yeah, the most important part of this model, why my choice was this, is because its sediment transport module is an open source module which can be freely coded, and that is what I have done.
That was during your time in Norway. Like, I know you went for some exchange program to Norway or something.
Not really, because
okay.
No. I did some laboratory measurements, and that's therefore.
In Norway?
Yes.
But did you work with these people like Niels?
Yes.
Oh, so you work with the developers of that model? Did you work with the developers of SSIMM2?
Yes.
Okay. Entonces, Gergely decidió usar un modelo 3D diseñado en Noruega, y él mismo fue hasta allá a trabajar con el profesor Niels, haciendo experimentación en laboratorio, o sea, con la misma persona que diseñó el modelo, que él implementó en la modelación numérica. Y aquí pues.
So test was like I wanted to see what the Van Rijn and the Wilcock model calculates for a 100-year flood. And these two figures show the results. The left shows the Van Rijn model, and the right one for the Wilcock model. We didn't have measured bed levels, so that I couldn't compare these results with measured real changes, but we had data. So we could imagine what is realistic and what is not. And what we found is that the Van Rijn model overestimates the changes. Meanwhile, the Wilcock model calculates quite well the bed changes in the mainstream. That is, the bed is armored, therefore stable there. But in the near bank regions, we expect much higher changes which cannot be seen in this case.
But wait, so you said you simulated 100 years in the past or future?
No, a 100-year flood.
Oh, flatbed?
Flood wave, yes, only one flood wave.
But so wait, so 100 years of the hydraulics, or
no?
why flood? Or
one flood wave, but
100 years flood discharge.
Yes.
Oh, okay. Got it. So, thank you, Laura. So, Gergely lo que hizo fue simular la descarga de los 100 años para ver la predictibilidad de los modelos. Pero encontró que, so you didn't find that neither of the models were accurately, no? According to what you say here. So you, according to your results, neither of the results were accurate to simulate.
Yes.
Yes. Sí, entonces de lo que él encontró es que ninguno de los modelos pudo simular correctamente el transporte de sedimentos con la descarga de los 100 años. Yeah, sure, sí, continue.
Okay, so what my idea was to compare these two models, so to somehow to use them parallelly and establish a combined application of these two. And my goal was to activate the Wilcox model in the mainstream, where the bed armoring process and the selective erosion are expected. Meanwhile, the other fine model should calculate the sediment transport where the bed material is much finer.
Mm-hmm.
But the question was how to describe the criteria which decides which transport formula to be activated in a given point, in a given calculation cell. Or with other words, the same question, with other words, how to identify if the gravel or the finer sand materials dominates in the bed load.
Entonces la pregunta que él se hacía para decir cuál modelo, but the hypothesis one was like, yeah, can you go back? So you have those models that were one for sand and one for gravel. So you were testing a combination of those?
My hypothesis was that the combination of these two can result in much better.
Okay. Entonces la hipótesis de él era que si combinaba esos dos podría predecir mejor el transporte de sedimentos ahí. Now for the second, yeah. Entonces ahora la segunda hipótesis era si lo que estaba dominando más el transporte era la parte de las arenas o las gravas. Yeah, keep going. Really.
And I suppose that the shear Reynolds number is a proper parameter for this. And yeah, I tried to be a bit quicker. So I investigated the laboratory and field measurements for which the Feinrein and the Wilcox models were validated. And the main outcome of this investigation is that there is a correlation or connection between the shear Reynolds number and the domination in the bed load. Namely, the higher the shear Reynolds number, the gravel domination is higher.
Okay, so let me explain that. Entonces lo que él vio es que había una relación entre el número de Reynolds, pues sí, entre el número de Reynolds y la tasa a la que, o la grava o la arena se movían, ¿no? Entonces, a mayor número de Reynolds, it dominates the sand. No.
Here dominates the sand and here the gravel.
So the higher the Reynolds number, like the coarser the material that dominates, right?
Exactly, correct.
Entonces, entre mayor número de Reynolds, mayor es el tamaño del sedimento que va a dominar la modelación.
And the equilibrium at which the two transports are in equilibria, or they are almost the same, is around 300 and 400.
Mm-hmm.
And yeah, and based on this investigation, I stated this decision criteria. And
so were you the first one to like find that, or like you find those numbers from the literature, or that was your results?
I think that these measurements showed this, but I haven't found an exact, I don't know, statement for that before. And also, I collected data from our own laboratory and field measurements to validate this statement. So this is the laboratory measurements which I have done in Norway. This is the sketch of this rectangular flume. We filled this flume with mixed sediment, and the groin or wing dam was installed in the middle of the channel.
Wait, hold on, go back. Bueno, estos fueron los experimentos que él hizo en Noruega, en el laboratorio, donde puso la... Was this a mix of the gravel and the sand?
Yes, it was a mixture. This is grain size distribution.
And it was all flat with the groin, like was the bed flat all the way in the experimental site? Like you didn't include any bed forms or anything?
At the beginning, at the initial state, not, but during the experiment, score hold.
Yeah, okay. Entonces en el experimento él puso la cama de sedimentos plana a lo largo. Entonces dice que la estructura que puso acá pues generó el movimiento y la erosión en este sitio. Yeah, keep going.
So we were able to monitor the bed changes. We elaborated 3 experiments with 3 different steady discharges and measured the equilibrium bed surfaces based on photos about the bed surface. We were able to do some image-based grain detection, and so the grain sizes could be described or obtained. And what else? We could measure the outwash sediment discharge, and also we used ADV to measure the flow features.
Okay, so you presented this in a conference in Switzerland?
Yes.
Bueno, aquí Gergely está mostrando uno de los resultados que él presentó en una conferencia en Suiza, en el que muestra pues los resultados del laboratorio de elaboración que hubo alrededor de la placa que puso en la mitad de la zona experimental. Can you repeat a little bit the graph, like the results Q1, Q2, Q3, just to make sure that I'm understood?
Again, sorry. What?
Can you repeat like your results from this graph, the Q1?
This is, yeah, this graph shows only that we elaborated 3 experiments. The first one was in the first case we ran in the channel 58 liter per sec. So this was the steady flow. This and once we reach the equilibrium, then we increase the discharge and.
Got it. Entonces él utilizó 3 descargas diferentes y ahí están los resultados. Obviamente la mayor descarga pues, va a generar la mayor erosión, como muestra ahí en los resultados de la derecha. Yeah, keep going. Got it.
Okay. And also as to the field measurements, mainly we use ADCP for the bed topography measurements and also for the flow measurements to review the flow structure. We do fixed and moving both measurements. And the important point is that once you have fixed both ADCP measurements, then by fitting the logarithmic velocity profile, you can estimate the bed shear velocity of the bed shear stress.
Bueno, aquí Gergely muestra las mediciones con ADCP del flujo ya en el campo, los perfiles de velocidad que él tomó para contrarrestarlos pues, después con el movimiento de sedimentos, pero esta es solo la parte del flujo. Yeah, so you are showing just like velocities, right? And,
yes.
And shear velocities. Okay, yes. Sure.
And also from the same points where we did fixed boat measurements, we collected bed material samples, and based on this data, the relationship or the relationship between the local bed shear stress and the bed material grain sizes could be investigated, and yeah, this is important because I use this data for the validation of hypothesis too.
Yeah. And aquí está mostrando cómo también recogió las muestras de sedimentos. How do you call that device, the sampler?
This is a bucket sampler. Yeah, nothing special.
Okay. Simplemente uso como un balde para medir los sedimentos que pasan por los diferentes puntos. And did you sample at different depths?
Yes. Here are the points where we collected samples.
Yeah, I mean, yeah, the location, but also at different depths, like nearer to the bed or like.
These are bed material samples.
Okay. Okay. So it's just like you were sampling at the bottom and at the bed.
Yes.
Entonces él con su cubeta pues estaba tomando las muestras de sedimento en el fondo. Okay, keep going.
Oh, sorry, I do have a question regarding the last graph. So the two samples that you show for the bed shear stress marked with a red circle, what does it mean? Like those are the outliers or those were the worst cases that you found? In the next slide, sorry. When you have the D50 versus the next slide. That one.
Yeah, these two.
These two? Okay, so we found a quite good trend, which shows that the higher the bed shear stress, the coarser the bed material. But in these two cases, these two points are different from this trend. Or they don't follow this trend, and or explanation for this is that these 2 points are from somewhere here where the beds are more just broke up. And that's why.
Okay, so they are the outliers and were neglected in your study. Or just to have it clear. So those two, I mean, the D90s or the D90 that is at around 10 millimeters.
Yes.
Those two didn't fit to the model that you were proposing, according to the field measurements.
I didn't hear the.
Okay, I'm just asking if the two D90s that you have like around 10 and 20 millimeters for bed shear stress of 4 and 8 newtons per square meters.
Okay.
Those two are the only that didn't fit to your model, to what you were proposing, that it will be the load of sediment, the sediment load.
I think this phenomenon it doesn't connect with this sediment load. If I understood you correctly, then you is because of the change in the sediment transport rate, right?
Okay. Okay.
It's not about that. It's more like the bed surface. Somewhere the bed surface is armor, but once higher flood wave comes and the bed shear stress increase, then this armor can break up, and below the armor, very fine materials can be found.
Okay, I see. Thank you.
Wait, Laura, can you translate the question and the answer so people can understand?
Claro, mi pregunta es ¿a qué se debe el cambio, especialmente con un estrés, un esfuerzo, un bed shear stress de alrededor de 4 o 6 en el eje horizontal? Porque si vemos el diámetro promedio de un tamizaje de 90 disminuye drásticamente de 70 a casi 10. Y la respuesta es porque si ves a la imagen izquierda, el diámetro del sedimento es mayor, pero la parte en blanco que se ve entre el kilómetro 1796 y el 1795 es prácticamente la planicie de inundación y ahí solamente quedan los sedimentos finos. Entonces ves esta diferencia bastante grande de 40 a 10, si fue lo que le entendí bien.
Gracias. Yeah, keep going, Gergely.
Okay. So I use this data, all of the data from the laboratory and from the field measurements, and the graph or figure shows the bed shear stress values as the function of the D50, and the main message of this is that the shear Reynolds number of 350 separates quite well the points which were collected from the main channel where the gravel load dominates, from the other points where the fine sediment transport dominates.
Bueno, aquí lo que Gergely muestra, bueno, la validación del modelo, entonces tomando el D50 como referencia, encuentra las so you have the Bezier stress and the Reynolds of the particle, and also the
particle Reynolds number and the shear Reynolds number.
Yeah.
The Reynolds number doesn't depends on the shear Reynolds number, and that's why this is a constant value here.
Okay. Sí, entonces para este Reynolds de la partícula pues, es constante y por eso está ahí. And then can you repeat like the 350?
Which part?
Like the explanation of like this Reynolds shear stress.
Okay, so the only message is that this line where the shear Reynolds number holds this constant value 350. This line separates well the blue points from the black points, where the blue points are from the main channel where the gravel dominates, and the black points represent the opposite.
Entonces los azules es cuando la grava es dominante para estos valores en comparación con la arena en los cuadrados negros. Okay, I got it. Yeah, keep going.
Okay, so these two figures were already presented, and this is the results by the combined method. And so I would say that the benefits of both models, of the Fine and the Wilcox models, are included in this scenario where the model represents quite well the stable armored mainstream, and also it predicts some bad changes in the growing fields and in the near bank regions.
And that's way more accurate than just like the separate models, ¿no? Of course.
Yes.
Entonces aquí está mostrando que lo que él probó combinando los dos modelos por separado, pues ya finalmente da unos resultados más acertados a lo que se midió en el campo.
And I had data for bed levels for no, I could calculate the bed changes for a 2 years long period, and these bed changes can be seen here in the top figure. And also I calculated with this combined method the bed changes for this 2 years long period. And what found is that the calculated method again resulted in a much better qualitative match with the measured data. But on the other hand, important to highlight that there are still many uncertainties, so
yeah,
many more improvement needs to be done in the future.
Sí, lo que dice aquí Gergely es que bueno, pues claro, el modelo puede calcular, uno ve que ya está más o menos comparable, pero de todos modos pues siempre hay incertidumbres y siempre bueno, hay espacio para poder mejorarlo. So the squares that you are including in the graphs are the places where you see like are more uncertainties?
No. Opposite. For example, here I was glad that my model was able.
Where you had better results.
Yes.
Okay. Entonces en los cuadrados que él puso muestra como donde él piensa que obtuvo mejores resultados. Sure, keep going.
Okay, so this was my PhD part, and now I'm going to talk about, but only a few slides, but I'm not sure, Andres, if you want to be.
Yeah, we can maybe stop here to see if people have questions.
Street with the 1 hour, I can stop here. This is what I'm very interested in.
Yeah. ¿Alguien tiene alguna pregunta que yo pueda traducir acá para él?
Si estos modelos son aplicables, ahorita que estamos en lo del proyecto de navegabilidad del río Magdalena, son aplicables.
Que se está entrecortando mucho. Profesor Jaime Suárez.
Yo preguntaba si estos modelos son aplicables.
Reynolds number that of the models. It looks to me is a very slow flow. A very slow flow. And how to apply that to Colombian rivers with velocities of more than 5 meters per second and turbulent flow.
This calculation method?
What was the velocity that you measured, Gergely, just to compare, because he's saying like more than 5 meters per second or something.
No, here in the Hungarian Danube, around between 1 and 2 meters per second. So much slower.
Right. Sí, entonces allá en el Danubio están las velocidades entre alrededor de 1 metro por segundo, comparado a lo que dice el profesor Jaime Suárez, de que acá pueden alcanzar 5 metros por segundo en Colombia. So you think like we will need a different model for like higher velocity or something, or it's still valid?
I think it's a shear Reynolds number, bed shear stress value dependent, and not velocity.
Yeah. Sí, lo que dice Gergely es que lo que importa más en este caso es el esfuerzo sobre el fondo, no como tal la velocidad media del río. Entonces puede ser que la velocidad media sea mayor, pero puede que se genere menos esfuerzos en el fondo. The stress depends also on the bed material.
Also, yes. So,
Claro, el esfuerzo va a depender también de qué tipo de material haya en el fondo. Profesor Suárez, ¿sabe si el Magdalena por lo menos es más arenoso o tiene más grava? Let's see if he replies.
Es principalmente grava en la mayoría de la longitud del río. Ya llegando a Barranquilla, pues es más arena. O sea, our rivers are mostly gravel and we have a very high gravel and fine and
Well, he said like in Spanish that some part it's mostly gravel, but then at the end
and medium size or more than 5 centimeters in several cases. So, and
I think the main question or this method is recommended to use in cases where the gravel and the fine material can be found next to each other, but the gravel is real gravel or coarse material, and the fine material is very fine. And but these two kind of parts of sections of the rivers can be found within one river section.
Sí, bueno, lo que él estaba probando de su método era cuando había el caso combinado, ¿no? De todos modos, so you say like there are like the separate methods, no? For well, the original models are mostly for sand, right? Like
Yes.
sí, los métodos originales están desarrollados y validados más que todo para arenas. Is there a method for like coarse material only or mostly?
Yes, there are.
Sí, pero también entonces hay los modelos para material grueso. Entonces habría que mirar qué modelo se podría aplicar que sea válido para las condiciones colombianas, ¿no? Yeah, so I think it's so these models are like universal, you know, and like it's just like a matter of defining what kind of material you have at the bottom and then choose the appropriate
is there a
model.
Reynolds number limit?
Excuse me, I didn't hear the question.
¿Puede repetirlo, profesor Suárez?
I think he wants to know which are the limits for the Reynolds numbers.
Number limit to use the model.
Okay, so below this 300 here. So once the shear Reynolds number is below 300, then the sand load dominates, and that's why the fine Rhine model is activated, and above 400 the other model, and between the two the weighted average of the two calculation gives the sediment transport rate.
Right. Sí, profesor Suárez, más o menos esa es como la referencia. Si el Reynolds, los esfuerzos de Reynolds están por debajo de 300, va a dominar la arena. Si están más de 400 de grado, entonces tendríamos que tener los datos de campo, las mediciones para saber cuál modelo usar. Ya, ¿hay alguna otra pregunta? We have like 5 more minutes to see if someone else wants to add something.
Okay. Just very briefly and quickly. So
Sure.
this.
Yeah, keep going.
Okay. So this is the place where we want to, or our plan is to establish the sediment transport monitoring station. And in this project, we work with the Austrian university, and where the head of the research group is called Professor Helmut Habersack. And within this project, we were able to buy this quite nice vessel, and the main advantage of this vessel is that we could install a multi-beam on this, and therefore from now we are able to monitor the movement of the dunes. Sorry.
Ajá. Entonces dice que trabajó también con un grupo austriaco, con el cual pudieron comprar esta barquito, lancha, para poder seguir el monitoreo. So how often do you sample now with this vessel?
Sorry, how often?
Yeah, do you sample with this vessel? Like once every month, once every year? Or
No. It's important to do, but are we talking about the topography measurement?
Oh, that's like for the bathymetry, or like are you taking the sediment
samples.
concentrations?
Both, everything. So we do our measurements based on the water stage, because we are focusing on the higher.
Entonces él toma las mediciones de acuerdo a las descargas de agua para ver las diferentes condiciones, cuando hay más descarga o menos. Yeah. Is there any, well, I guess like in the spring season, you get like more flood, more discharge, and then you measure there and then have that as a reference.
Yes, that is what we are doing now. Yeah.
Entonces en la primavera, cuando después del invierno que empieza a llover y todo, pues hay mayores descargas, entonces ahí es donde salen a tomar las mayores mediciones. Hay una pregunta. Is there any other instrumentation installing the river, like besides this vessel? Like
yes.
Okay.
So this sketch shows what we are planning to do. So the monitoring station will have ABS, OBS, and the horizontal ADCP. The ABS and the OBS are devices which calculates the suspended sediment concentration indirectly. But Andres, I don't know. Should I explain it, or everyone is familiar with these devices?
Yeah, I'm not sure, but yeah, like take like a few minutes to just wrap up with that. So yeah, they also want to know like what do they need to measure? So how does it work, an ADCP system? Yeah.
Okay, so the ABS calculates the suspended sediment concentration from the reflected acoustic sound. The OBS does the same, but from the optical signs. And both devices collect this data from one point, from the point where these devices are installed, and this is the right takes place at the right bank.
Okay, 1 second there. So lo que está diciendo es que estos instrumentos funcionan con el método de Doppler, entonces mandan una señal acústica que choca contra las partículas y ahí el choque devuelve y el instrumento recibe la medición. So it measures the concentration at every point, or what is the output? Or,
no, only one point, only here.
Oh, okay, you choose one point.
And this.
Okay, but that's the ABS. It's for flow or sediment.
Both for sediment. Both for sediment.
Entonces, con eso miden la velocidad del flujo y el sedimento que pasa por un solo punto.
Yeah. But these two devices give you data only from these points.
Yeah.
you need another method which provides you data from the whole cross-section. And therefore we do the both ADCP measurements, and we collect samples from other verticals and more points from one verticals. And also the horizontal ADCP collects the velocity data, but only from one level, one layer of the cross section.
Nice. Sí, entonces ya con el ADCP pues se puede hacer todo un perfil y obtener la distribución de las velocidades a través de la sección transversal. Okay, Gergely, I think it's a good time to stop. I really appreciate. I mean, I wasn't ready to be translated simultaneously, so it was very challenging for me. But yeah, I appreciate your time preparing this, and I have learned a lot from your experience. Very interesting. So yeah, let me say some few words in Spanish that everybody know that we are closing.
But please tell them that I'm very grateful and thank you for your invitation and also the questions and interest.
Bueno, vamos a cerrar por acá. Gergely también está muy agradecido por la invitación. Me disculpo que no estaba preparado para estar traduciendo simultáneamente, así que traté de hacer lo mejor que pude. Gracias a Laura por la ayuda. Gracias a todos por acompañarnos, las preguntas, y esperamos nos sigan acompañando dentro de un mes. Así que buenas tardes a todos, and good night, Gergely. I will talk to you later.
Thank you.
Okay, bye.
Bye.
Sí, gracias. Ya Gergely desde Budapest, ya medianoche, y a Andrés desde Chicago. Estaremos todos los terceros jueves de cada mes preparando charlas interesantes. Esta que nos enriquece sobre el manejo de navegabilidad del río Magdalena. Entonces, tener consultores que nos puedan apoyar en su momento. Bueno, muchas gracias a todos. Una feliz noche.
Hasta luego.